video is going to be an introduction into the kind of math problems that you're going to encounter in acid-base chemistry. So most of you are probably already familiar with what we call the pH scale. So the pH scale. And most of you at this point have learned that the pH scale is basically a scale that measures acidity or basicity, and it runs from 0 to 14. So you've probably encountered this before. If not seeing in your chemistry class, you probably saw in your biology class or sometime before that. So all the pH scale is that. It's a scale that runs from 0 to 14. Well, in addition to pH, there's another scale, which we call pOH. So, you know, it's pretty much runs the same way. It runs from 0 to 14. And what you might know about the pH scale is that within the pH scale, if the pH is less than 7, we say that it's an acid. If the pH is greater than 7, we say that it's a base. And if it is 7, it's neutral. Well, for the pOH scale, it's pretty much the same thing. It's just flip-flopped. If the pOH is less than 7, it is a base. And if the pOH is greater than 7, then it's simply an acid. So it's really is the exact same thing. pH, pOH, almost synonymous. In fact, there's as far as their math goes, they're definitely different in what they're calculating. But there's a mathematical equation that relates the two, and that equation is that your pH plus your pOH equals 14, and that should kind of make sense. Let's say you have something that has a pH of 3. Well, if it has a pH of 3, then its pOH would end up being 11. And so the pH of 3 corresponds to an acid as it's less than 7. And a pOH of 11 also corresponds to an acid because it is greater than 7. Forgot to write that in here. pOH greater than 7 is an acid. So alright, so that's pretty cool. Those two are related to each other. Next thing I want to talk to you about is just what exactly does P mean? So this P is actually a mathematical operator, and P simply means negative log base 10 of. So when you're doing pH, your pH just simply means the negative log base 10 of H, your H plus concentration. Your pOH simply equals the negative log base 10 of your OH minus concentration. So that's what P means, and you can apply it to anything. You can have pKa, you can have pKp, you can have P anything, just means negative log of that value. So let's continue on here, and if you watched the equilibrium videos before this next part should probably be very intuitive to you. If not, it's probably a good idea to go ahead and review those. So what we know about water is water can and does randomly hydrolyze into H plus, which is aqueous, water over here is a liquid, and OH minus, which is also aqueous. We know that KEQ, or the equilibrium value, is simply equal to products over reactants, and we don't include liquids. For water, we call this very specific equilibrium constant KW, and it's equal to the concentration of H plus times the concentration of OH minus. So this KW value has been calculated, it's been determined, and what we find out it's equal to is KW is equal to 1.0 times 10 to the negative 14th, and that's equal to your concentration of H plus times your concentration of OH minus. And this is actually, it's from this equation that we're able to derive this pH plus pOH equals 14. I'm going to go ahead and take you through that. It's just going to help refresh you with logarithms. So remember that P just means the negative log of. So what I'm going to do here in this equation down at the bottom is I'm going to take the negative log of both sides. So ignoring the 1, this will become the negative log base 10 of 10 to the negative 14th. And on this side, it's going to be the negative log base 10 of your concentration of H plus times your concentration of OH minus. Alright, well, what can we do here? If you remember the exponent rule of logarithms, I can take this negative 14 and bring it to the front. So the negative of the negative 14, this just becomes 14 log base 10 of 10 is equal to, when on the right side over here, when you're multiplying logarithms within the log, you can actually split it out in a division problem. So this is going to become negative log base 10. I'm going to add here, but then because this negative sign's in the front, I'm actually going to keep it as a minus sign. So this would be plus, but instead it's going to be minus here. Log base 10 of OH minus. So this is what we get here, and let's try to simplify it a little bit more. Well, the log base 10 of 10 is simply 1, so this just becomes 14. And, well, I can replace this negative log base 10 with pH, and I can replace this negative log base 10 of OH minus with POH. And that's where that formula comes from. It's from this KW. It's from the equilibrium expression. And you're going to be required to use a lot of these different rules in your mathematical calculations. I'm going to make a nice summary of all the formulas here on the right side. So this is really what you want to write down. This is what you're going to be using throughout the class. So let me write in, let's do an orange. So as discussed, your pH plus your POH must equal 14. pH just means the negative log base 10 of the H plus concentration. This formula can be flipped around so that you have 10 to the negative pH is equal to the H plus concentration. Very similarly, we can have POH is equal to negative log base 10 of your OH minus concentration, and therefore 10 to the negative POH is equal to your OH minus concentration here. And then, of course, back down to KW. KW is equal to 10 or 1.0 times 10 to the negative 14th. And we also know that KW is equal to the concentration of H plus times the concentration of OH minus. So these equations here, these equations that are nice and in orange and not too neat, but hopefully readable. These equations are the ones that you really want to write down. You're going to want to memorize them, or at least know how to derive them from the other ones. And that's going to be it for this video. In the next video, I'm going to talk about a few different types of calculations that you might see. Take you through some example problems.